Welcome to Easy Elimu Learning Simplified. My name is Eric. I'll be taking you through the topic divisibility tests, and for this lesson I'll be taking you through divisibility test for 2, and then we look at the divisibility test for 3. So we will start by trying to expose us to what divisibility tests are all about, and then after that we look at the divisibility test for 2, then we'll go to the divisibility test for 3, and then after that we'll be able to give you some of the questions involving the divisibility tests, and then basically that will be helping you with practice and to help you gauge your understanding of the topic of discussion for this lesson. So we are starting with the divisibility test for 2. So what is the condition that you need to see to confirm that a number is divisible by 2? So the condition is here as displayed on the screen. We say that any given number will be considered to be divisible by 2 if the last digit is either 0 or is an even number. So if there is that typing error there. So the word is if. So we say a number is divisible by 2 if the last digit is either a 0 or is an even number. And we have examples here where the last digit is 0. We have 2 even number, we have 4 even number, we have 6, and of course we have 8 there. So you just need to check whether the last digit of a given number is even or whether it is 0, and then you'll be able to confirm that that number is divisible by 2. So we say that a number is divisible by 2 if it is divided by 2, then the quotient is a whole number. For example, if you talk of 20, you divide it by 2, the answer is 10. So you can see our quotient is a whole number 10. So in this case, we are considering 20 being divisible by 2 because 2 goes into 20 10 times, exact number of times without leaving any remainder. We would consider the remainder to be 0. Also, if you look at 32, for example, you divide it by 2, the answer is 16. So it means 2 divides 32 exact number of times. And therefore, it is considered, 32 there is considered to be divisible by 2. Let's look at 254. So 254 you divide by 2. You can see, 2 goes into 2 here once. 2 goes into 5 twice, the remainder is 1. That 1 is taken to the next digit as 10, so it's 14. 14 divided by 2 is 7, meaning that if you divide 254 by 2, the answer is 127, which is an exact number of times. So then this number is considered to be divisible by 2. So you can see we have proved that this number is divisible by 2, this number is divisible by 2, and this number is divisible by 2 by basically doing the long division. So you don't have to do all this all the time to confirm that a number is divisible by 2. You basically need to find out whether the condition that is set for divisibility for 2 is met or not. So the condition is on the last digit of the number. You simply need to check the last digit of the number. So what about the last digit? So the last digit must be even. You can see using the long division, we have this, and this. Both of them are divisible by 2. But as well, you can see that the last digit here is 0, the last digit here is 2, and the last digit is 4. So you only need to check the last digit. Once we have confirmed that the last digit is either 0 or an even number, it's an even number, then you'll be able to conclude that that number is divisible by 2 without looking at the other digits. So all of them that are listed on the screen are supposed to be divisible by 2. So let's look at the first example here. Which of the following numbers is divisible by 2? So remember, the condition for divisibility for 2 is on the last digit, that the last digit must either be 0 or an even number. That means the last digit can be 0, 2, 4, 6, and 8. So you'll only need to confirm that the last digit is any of these numbers: 0, 2, 4, 6, 8. Otherwise, if that is not the case, then that number will not be divisible by 2. So if you check the first number, which is 23445, you realize that the last digit is 5, and 5 doesn't fall in the category of even numbers, so 5 is odd. That means this number is not divisible by 2. So if you try to divide the number 23,445 divided by 2, you'll get a remainder. It will give us a quotient and a remainder. So that means the number is not divisible by 2. So how do you frame the answer then? So you'll say 23,445 is not divisible by 2 because the last digit is neither even nor zero. So the last digit is not taking any of the numbers, so it's neither even nor zero. So that is the reason that you'll give why the number is not divisible by 2. So it's supposed to be either even or is a 0. So if it's not the case, then that means that number is not divisible. So let's look at the next number, 3453. So this one, again, you check on the last digit and realize that the last digit is not even. So you'll talk of the number. This is how you're supposed to frame your answer. The number 3453 is not divisible. It's not divisible by 2 because the last digit is neither 0 nor is an even number. So it's neither of the two. So it's neither even or nor is an even number. So it's not any of the two. So we have confirmed that the number there is not divisible by 2. So let's look at the last one here, 3,456. So you'll conclude and say 3, 4, 5, 6, that is 3,456. You only need to check on the last digit and you realize that the last digit is even. So how do you frame the answer? So 3,456 is divisible. So it's divisible by 2 because the last digit is even. That is the reason that you'll give for justifying why you say the number is divisible by 2. So you have to restate the condition. Remember always to restate the condition as evidence of the answer that you're giving. So you talk of the number 3,464 is the one that is divisible by 2 because the last digit is even. Remember, that is one of the conditions. Either the last digit is supposed to be a 0 or is supposed to be an even number. So let's look at example number 2 here, as displayed on the screen. The question is, what is the smallest number which can be added to 2,345 to make it divisible by 2? So you realize that this number here is not divisible by 2 because the last digit is not even, nor is it a 0. So if you want to do this, you say let the number be x or n, or let me use n here because of number, trying to use initials. Every time you're using letters to represent actual numbers, you try to use initials. So we have 2, 3, 4, 3, 4, 5. You add a particular number should give you, remember we're talking about the smallest. that needs to be added here. So what is the smallest attainable that will make this number here to be divisible by 2? So this one here can be 2,346. In fact, here we needed to state what is the smallest positive number. What is the smallest positive number which can be added to? So take note of that. Correction supposed to be what is the smallest positive number which can be added to make it divisible by, yes, so that there is an increase. So that there is an increase in this number here. So it's supposed to be 2,346. So then it means n is going to be 2,346. So if this cross the equal sign to the other side, it becomes minus 2,345. And of course, the answer here is going to be 1. Remember, you can add 1 to make it 46. You can also add 3 to make it 48. So the last one here is 8. So that's why the word here, smallest, is very important. So the smallest positive number which can be added to the given number there to make it divisible by 2 is 1. Now, on divisibility test for 3, the condition that is supposed to be set here, or the condition set that we need to see to be able to conclude that the number is divisible by 3 is that the digital sum should be a number that is divisible by 3. So if a number is divisible by 3 if its digital sum is divisible by 3. So we have examples here. Digital sum here, you sum this 1 to 2 will give us 3, and 3 is divisible by 3. 1 to 5, that is giving us 6, and 6 is divisible by 3. 1 to 8 is 9, 9 is divisible by 3. 1 to 2, 3, 3 is divisible by 3. 2 to 4 is 6, and 6 is divisible by 3. 2 to 7 is 9, and 9 is divisible by 3. 3 plus 0 is 3, and 3 is divisible by 3. 3 plus 3 is 6, and 6 is divisible by 3. 3 plus 6 is 9, and 9 is divisible by 3. And the last one here is 3 plus 9 is 12, and 12 is divisible by 3. So that is how you'll be able to check that a number is divisible by 3 or not. You simply sum up the digits, add the digits. If it gives you a number that is divisible by 3, then you can then conclude that that number is divisible by 3. So we have the numbers listed like 12, 15, 18, 21, all of them, right from 12 here to all the way to 39. They are all divisible by 3, and you can confirm that the digital sum of each is a multiple of 3. So we have the first example here. Which of the following numbers is divisible by 3? So what you'll do if you pick like the first one, 23, 44, 5, you just need to sum up the digits. So here you will simply sum up the digits. So 2 plus 3 plus 4 plus 4 plus 5. What do we get? So we have 2 plus 2 is 5. This is 9, this is 13, and this is 18. So you can then conclude that the number 2, 3, 4, 4, 5 is divisible by 3 because its digital sum is, so you have to give evidence of what you got. So you can't say is divisible, you have to give evidence. So our evidence here is 18. 18, and 18 is divisible. 18 is divisible by 3. So we have given the evidence of what you were able to find out as we are doing the test. In doing the test, we realize the digital sum is 18, and 18 is divisible by 3. So we then conclude that the number is divisible by 3. So this is example number 2 on the divisibility tests for 3. What is the smallest number? Smallest again, positive. So what is the smallest positive number which can be added to make it divisible by 3? But we are looking at divisibility test for 3. So what is the smallest positive number which can be added to 2345 to make it divisible by 3? So again, you talk of let the number be n. So 2345 plus n should be equal to. So I don't know whether this is divisible by 3 or not. Let's see. So we have, if you add this one here is 5, and 5 plus 4 is 9, and 9 plus 5 is 14. So we are trying to find a number here that can be added to make it such that when you sum up the digits, you'll be able to get a number like, for example, 18. So far, adding 2 to 3 is giving us 5. 5 plus this is 9. And 9 plus this is 14. 9 plus 5 here is 14. So we are looking for this so that it is added to the rest of the digits, we'll be able to get something like 18. So that means this can be 9. So we have 2. So we have 2, 3, 4, 9. So we have then n is going to be 234. Okay, 2349. You subtract 2, 3, 4, 5, and you can see that the answer here is 4. So it's something that you are able to do even by inspection without really going through the algebraic expression. You can still just inspect and see what you need to add to this 5 to make the sum of the digits within this number a multiple or a number that is divisible by 3, like 18. So that is supposed to be 4. So you simply sum up the digits, you add the digits, and then you see the remainder. So alternatively, this is what you're going to do. You're going to add 2 plus 3 plus 4 plus a number that will be inclusive of this 5 should be equal to 18. So that n, so we have 2 plus 3 is 5 plus that is 9 plus n should be equal to 18. So that n here should be equal to 18 minus 9, which is equals to 9. So the number that we are looking for is inclusive of 5. So we have the number is m, you add 5 should be equal to the difference here. The difference here, which is 9. So this is going to give us m should be equal to 9 minus 5, which is equals to 4. So that is an alternative approach. Now remember, I've said you can just do it by inspection. You just check what do you need to add to this 5. What is smallest that you need to add to this 5 to make the sum of the digits within that number being a number that is divisible by 3, like 18. You see, that is the essence of positive, that we need to add something to this. So we have a short question here to help you with practice, and we have a short question here to help you with practice and just to get your understanding of the concept of discussion that we've been discussing through this session. So the question is here, which of the following numbers is divisible by both 2 and 3. You can always post the working on the comment section. You'll be able to look at it, and then you'll get to give feedback accordingly. Otherwise, that marks the end. Goodbye.